welcome to your lesson. Even though I'm not here, I'm still watching you all the time. So today we're going to talk about graphing, and specifically we're going to be graphing absolute value functions. So you might remember when we were working on the domain problems that you would see things that look like this. Y is equal to the absolute value of x. So first of all, let's just think about what this graph looks like. Remember that the domain of absolute value is any number for x that I want, all real numbers. Anything that I put in here will work fine. But what comes out, so the domain, the x values, is all real numbers, and the range, what comes out of this, the y values, are all positive. Because anytime I take the absolute value of a number, it's always going to be a positive number. So it would be something like y is greater than or equal to 0. So the first thing that I want to do is just start off with a little table. So I'm going to do an x and a y, and I'm going to plot these points. -3, -2, -1, 0, 1, 2, and 3. So I'm going to substitute these x values into this x here and see what happens. So if I plug in -3 for x, the absolute value of -3 is +3. So that comes out as a positive number. And then if I plug in -2, the absolute value of -2 is +2. And then if I plug in -1, the absolute value of that is 1. And the 0 is just 0. And then these are already positive numbers. Nothing's going to change when you plug it in. So I just get 1, 2, and 3. Now what I want to do is graph these and see what happens. So I'm going to have 0, 0, and then 1, 1, and then 2, 2, and then 3, 3. So if you look at the right-hand side of this, this really just looks like the equation y equals x. Goes through the origin. Maybe you could say that since this line goes through the origin that it would be a direct variation. But when you look at the left-hand side of this graph, that's when things change. Because normally we would expect the line to just continue down this way, but the absolute value, those bars on the side, make it so that it's no longer going to be a line. So look what happens on the left. I go -1, 1, -2, 2, -3, 3, and so that's really just the graph like this. So it's going to be a V shape, where one side is going to be the regular line, and then the other side is, think about it having just reflected over, right here, the x-axis. So all absolute value graphs have a V shape. And you can remember V because value starts with V, so they're always going to be shaped like a V. So if you think about this, we started off with just y is equal to the absolute value of x. So y is equal to the absolute value of x. So my slope here on the right, my slope is 1. But on the left-hand side, my slope is -1. So basically all graphs are going to look exactly the same. So if I graph something like this, y is equal to 2 times the absolute value of x, now that's saying that instead of my slope over here, like a slope of 1, now this is going to have a slope of 2. So the way that I would graph this is exactly the same. I don't really need to do a table. I just know that this one is going to go through the origin as well, because there's no plus anything out here. And then to the right, I'm going to do a line with a slope of 2, +2. So I go up 2 over 1, connect that part. And then on the left-hand side, I do a slope of, instead of +2, I do a slope of -2. So I go up 2, left 1. And that's a slope of -2. So this piece down here, the very bottom part, that's called the vertex, the very bottom of the parabola. I mean, sorry, of the V shape. So So when you're down here at the vertex, you always are going to do a positive slope on the right and a negative slope on the left. So if I try to do something like y is equal to the to 1/4 times the absolute value of x, then I would start at 0, 0. I would go up 1 over 4. I would connect that. And then on the left-hand side, I would go up 1, left 4. And then I would connect it like that. So it looks like a fraction is going to make it a wider v, and the absolute value, the whole number is going to make it more narrow. So if you notice, these are all having their vertex at the origin. So you think, wow, that's pretty boring to be stuck in the same place all the time. So then what we want to do is take these graphs and move them all over the xy axis. And it's pretty easy to learn how to shift these. And once you learn this for shifting with absolute values, it's actually going to work on every single graph that we do for the rest of the year, and frankly for the rest of your life. So the first thing I want to talk to you about is shifting up or shifting down. Okay, so shifting up or down. So if I have something like this, y is equal to the absolute value of x plus 4. This graph, because the plus 4 is outside the absolute value, this means that it's going to shift up 4. So if I'm going to graph this, I'm going to just start at my origin, but instead of starting there, my vertex moves up 4. So 1, 2, 3, 4. I put my new point there, and then here the slope is 1. So I go up 1 over 1 to the right, and then up 1 left 1 on the left. And it looks exactly like the original one that we did, except that everything's just moved up 4. Well, that's not very hard. So if I add a number to the outside, that makes it move up. So what do you think you do to make it move down? What? I can't hear you. All right. So if I want to move something down, let's try this. Y is equal to 3 times the absolute value of x minus 2. So now this 3 in the front here still stands for slope, so I'm going to have a slope of 3, but this minus sign means that it's going to go down 2. So that means that the vertex is going to be shifted down 2. And then from here, my new vertex, I graph a line with a slope of 3. So up 1, 2, 3 over 1. And then up 1, 2, 3, left 1. Okay. So before we go into shifting left and right, let's look at this y equals absolute value of x graph again, and think about something else that we could do to it. So we talked about how to make it move up and down, but what happens if I don't want my v to be going up? What if I wanted my v to flip over? So basically I want all of my x values to be opposite. So how do I make all of my x values opposite? I just do this. Y is equal to negative 2 times the absolute value of x. Now it has a negative slope. So now instead of your V shape pointing up, now your V shape is going to be opening down. Or you can consider that a flip. So still, since I'm not adding or subtracting anything, my vertex starts here at the origin. Now my slope is negative 2. So I go down 2 over 1. On the right side, negative slope. And on the left side, I go down to left 1. So that will give me an upside down V. So let's recap. So far, everything we know is if I have y is equal to plus or minus the absolute value of x plus or minus some number here. All right, if this number is positive, my V opens up. If that number is negative, my V opens down. If this number outside the absolute value here is positive, I'm shifted up. And if it's negative, I'm shifted down. So for instance, if I have plus or minus 5, here I would go up 5 if it's positive. If it was negative, I would go down 5. All right, so we can go up, we can go down, we can flip it over, and you might be thinking, okay, now I want to be able to go left or right. I don't blame you. You don't want to be stuck on the y-axis for your whole life. Very boring. So let's see. Now I want to shift right or left. And then we're going to combine everything together. So if I have this, y is equal to the absolute value of x plus 5, notice the location of where this number is. This number is inside the absolute value. So all of these always happen inside the ab val. All right, so that means if it's on the inside, you're going to be shifting it right or left. So if I have a positive number here, that means I'm shifting left 5. So I would graph this. I would start at my origin. I would go left 5. And then from there, I would just do my regular V shape with a slope of 1. So up 1 over 1, up 1 left 1. Everything's the same except it just moves to the left 5. Whereas if I want to go right, my number has to be inside the absolute value, so something like x plus, oops, not plus, x minus 2. So if I have a minus in here, I'm just going to go right 2. So I do my regular ab val graph. I go to the right 2. I go up 1 over 1, up 1 left 1, and I do my V. Okay, so that's basically it. Let's talk about combining them all together into one graph. So let's say I have this. Y is equal to 1/2 times x plus 3 minus 1. Now I know I have a slope is equal to 1/2. I know this plus 3 on the inside and it's positive. That means it's going to go left 3. And this minus 1 means it's going to go down 1. So what I do is I consider this stuff first. So I go left from the origin, left 3, down 1, and here's my new starting point. So instead of starting everything at the origin like I'm used to, I'm going to start right here. And then I'm going to attach something with a slope of 1/2. So I'm going to go up 1 over 2, and then up 1 left 2, and there's my graph. So the vertex now is at -3, -1, the opposite of what's here and the same as what's there. And then from that point, I do a slope of 1/2. Let's try another example. Now I'm going to do y is equal to -2. Oh my gosh, the negative means that the graph goes upside down. Oh yeah, I remember. Upside down. And then, let's do this. X plus 1 plus 4. So, instead of plus, we did plus last time, so let's do minus. So x minus 1, so if this is minus, that means I'm moving to the right 1. And if this is positive out here, that means I'm moving up 4. So I'm going to start at the origin, I'm going to go right 1, I'm going to go up 4. So my new vertex right now is 1, 4. And then from that point, I do a slope with -2. So from here, I go down 2 over 1, down 2 over 1, on the right and on the left. So I went right 1, I went up 4, the slope of 2, but it's negative, so everything's going to be upside down. Okay? I just have one more thing that I want to show you, and it is the one thing that people sometimes make mistakes on. So if I have something like this, y is equal to the absolute value of 3x minus 6, and I ask you how that shifted, a lot of you are going to look at this and say, oh, that's a -6, so it shifted to the right 6. But see this number right here in front of the x? That is inside the absolute value. And what you have to do is when you have the 3 next to the x, we want to take that outside the absolute value. So I'll show you the only way that you can do that. I have to factor the 3 out of this whole expression. So 3x, if I redistribute that, I get 3x back, and then minus 2. So see how I undistributed there? Now I'll just take the 3 on the outside. So 3 times the absolute value of x minus 2. So now, instead of like you were thinking it has a right shift of 6, you're really just going right 2 with a slope of 3. So I would graph that by going right 2, and then a slope of 3, up 3 over 1, up 3 over 1, and you're done. Okay, so you have some problems to work on in your worksheet. I'll show you which ones those are. I hope you liked watching me today. I'll see you on Friday.